Okay, so in this video we're going to talk about the normalization in 1D books. So if you have watched our previous videos, you know we have introduced a wave function for these 1D book systems as a sine n phi x over L, right? This is our wave function for 1D books. So this is our 1D book system. So this is 0, this is L, and here we have potential energy of infinity, and here also, and here we have potential energy of 0. So you know, the wave function kind of represents the probability of a particle in a specific position, right? If we have taken this region as our position, this whole region 0 to L, right, what would be the probability of finding the particle in this region? It is definitely 1, right? The particle must be in this region, otherwise the wave function is not right. So this is what we are using for our normalization conditions, right? So you need to know specific expression for normalization. So here what we are using here is our limits in 0 to L, this expression, our wave function times psi star dx must equals to 1. Now the problem is here, what is this? In this case, in our case, it won't matter. It only matters just like these cases. Imagine a particle, there's a particle, and the wave function of the specific particle is given by this expression, right? This is the expression which the particle is represented, right? So you know what this term is, right? This I is -1 square root, right? So psi star, this is mean by e to the power minus I m theta. Every time we are taking the this star term, we need to replace our I terms with minus I terms. This is why I told you that it doesn't matter in our this case, because we don't have I cases, so it's just the same psi over here, right? So just you need to remember these things. Okay, so let's move in. So I'm going to substitute for these expressions. Psi is our a sine n phi x over L times a sine n phi x over L. If we have integrated this would give the probability of the specific particle in this region that should be equals to 1. So I'm going to go with our simplification. A squared sine squared n phi x over L equals 0. Right. So you know there is an expression in geometry like this. Sine squared theta is equals to 1 over half 1 minus cos 2 theta. This is just an expression, you just can remember it. So I will use this equation to substitute for this my sine squared term, right? So here I have, so this is 0 to L a squared 1 over 2, I will use different brackets, 1 over 2 times 1 minus cos 2 times, now our this term here theta, we don't have theta, we have this term n phi x over L. So I'm going to simplify this fraction, 0 to L 1 over 2 a squared minus 1 over 2 a squared cos 2 n phi x over n dx. So by integration I can substitute like this. This is a constant, so by integration a constant we would have 1 over 2 a squared x, and our limits is L to 0 minus here 1 over 2 a squared, the cos here, the cos would turn into sine 2 n phi x over L, right? And we would have to multiply this to n phi L, right? This is just the integration, right? This is just the integration. You know, this is sine term, right? I will just like this sine 2 theta, this assume sine 2 theta. So if we have to integrate this, sorry, we will in cos here we have a cos term. Let's say cos n theta. We need to integrate it. So we would have sine n theta, and this inner constant, this n constant, must be divided, right? Because the integration is just the opposite of derivation, right? If we derivate this thing, we should get this our function. You can derivate this and you should really take in this function. So that's the basic concept over here. It's just the thing I have done here. So here I have got the expression. So this is L to 0. So I'm going to add the limits a squared L squared, 0 is just the 0 minus here, look at this, every time here this L in 0, every time this sine term is going to 0, right? This sine term is going to 0. I have explained the why it's happening right in our previous videos. So if you have not remembered, just quickly just remember, wrap it up by watching that small video. So this is just going to be 0, so it must be equal to 1. So then here we have 1 over 2 a squared n squared equals to 1. Here I can take an expression for a plus or minus 2 over L. In our simplicity, we would take a as plus 2 over L. So we have found all the constant in our wave function. For 1D box, the wave function would be 2 over L square root over sine n phi x over L. This is the wave function of a 1D box we have obtained. So this is just the concept of normalization. You can easily go into this. It's just a simple integration. Just try it twice or thrice, you can easily get it.